Let's talk about identifying when an association is linear or not. Whether there's an association between x and y at all is an interesting question. And if there is one, meaning knowing something about x helps you predict y, then we could ask, is that association linear, or is there some other relationship? One good way to assess whether an association is linear is to draw the residual plot that we just created. So this is a scatter diagram of residuals. There's one dot per original xy pair, or one dot per residual. The x value is just the x value from the xy pair. But instead of plotting y, we plot the residual, the difference between y and its regression estimate. Now, if the relation between x and y is linear, then this should look like an unassociated blob. And that's what we saw when looking at heights. If it still contains patterns, then there's probably some nonlinear association between x and y. We haven't captured that association by drawing a line and subtracting out the line's heights, and so what's left over is the association that's still there, even though we've drawn a line. And this can be used to check whether linear regression is an appropriate way to describe what's going on in the dataset, or to describe the relation or association between x and y. We're going to focus on a dataset about dugongs. A dugong is like a manatee. It's not a manatee. It looks kind of like a manatee. It's related, but it's not a manatee. Instead, it's a dugong. And some scientists went ahead and measured the age and length of a bunch of dugongs. We might wonder, is there an association between age and length? Well, dugongs actually just keep growing. But do they grow at a linear rate? Let's take a look. So here's a table of the age of a dugong and its length for a bunch of different dugongs. And there's a very high correlation between the two. You might think, if the correlation is that high, the association must be linear. But that's not a good conclusion to draw. You can have nonlinear associations that still have a high linear correlation. So here's a scatter diagram of the length of the dugong and its age. The blue dots are actual dugongs, and the yellow dots are the fitted values on the regression line. And yeah, that line looks pretty good until you look at the scatter diagram of the residuals. And you can see that there's structure here. For very low lengths, all the residuals are positive. For very high lengths, all the residuals are positive. And in between, most of the residuals are negative. If this association between length and age were really linear, then you would expect for any vertical slice, about half the dots would be above and about half would be below 0, with roughly equal magnitudes on both sides. Now, you could have seen this in the original scatter diagram just by looking visually at the comparison of the blue dot to the yellow dot, but I think the residual plot really emphasizes what's going on, makes it easier to pick out patterns using your eye. How about we do one more example? This one's even more extreme. What we have here is a table that has the heights of women in the United States, and then for that height, so all the women with height of 58 inches, what is their average weight? And is there a correlation between height and average weight? Extremely high correlation, 0.995. So that association must be linear, right? Wrong again. Here's the scatter diagram of the actual values. For each height, what's the average weight of women in the US? And here's the plot of the residuals. So as you can see, there's clear structure here. Again, too low for low heights. The estimates are too high for medium heights, and too low again for high heights. So you see positive residuals here, negative residuals there. And that's because there is a little bit of a curve to the blue dots, whereas the yellow dots are forced to stay on a line. Now the correlation is so high because the yellow dot is always near to the blue dot. And so if you use the regression estimate, you're not off by much. But you should be aware that using regression estimates in this dataset is not entirely appropriate because the association doesn't look linear. High correlation means a lot of the association can be explained by drawing this line, but not all of it. And the reason not all of it can be explained is not just because of random noise. It has this very clear structure where there's a curve in the blue points that we failed to capture with the yellow points.